Hello everyone. So welcome to the second tutorial. It was a Monday, so we're recording this so that you guys can access it. The first question we're going through is a tire manufacturer wants to determine the inner diameter of a certain grade of tire. Ideally, the diameter would be 570 millimeters. The data are as follows. A, find the sample mean, median, and mode. Find the sample variance, standard deviation, range, and coefficient of skewness. Using the calculated statistics, can you comment on the quality of tires? Provide a frequency histogram. Report quality of these data along with a table summarizing the group data. Find first, second, and third quartile, and then find IQR. Are there any outliers or extreme outliers in the data set? Plot a box and whisker chart of the data set. To get all these going, we have multiple steps to follow. For the first one, mean is super easy. You can see the equation here. Technically, what it means is that you need to sum everything, all the numbers that you have, and then divide it by the number of the values that you got. You do that, you will get a final value, which is 570 millimeters. And you can see that you have an ideal diameter up there, which that's why the different, like the sentence is after this. It's exactly at the target. The next step is calculating the median. For median, it's very important that you set the data up properly, and that means arranging it in an ascending order. You need to find a middle value. If the total number of values is even, at your average, you will average the two middle values. So if you count the numbers here, we have 560, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 numbers. For a total number of even numbers, there is no middle number, so you have to average the two number in the middle. Which if you do that and you calculate based on the equation, your median would be 567.5 millimeters. For the mode, technically what you need to do is for your, again, ease of coming up with the right solution, you put them in an ascending or descending order. Once you do that, you can have a clear view of what your data looks like. Once you have that, you start looking at the most frequently number that appears in your data set. In our case, once we arrange everything, it's easier to see what's happening. So we have two 566 and two 568. So you technically have two modes, and that's something we call the data set is bimodal. That's what it means. And that's technically how you find the mode. And now remember, for the mean, we really don't care whether the data is arranged in a particular type or manner. For median and mean, for median and mode, you need to put the data in either an ascending or descending order. Ascending order is normally better because it's just, it makes more sense. And that would be it for this part. The next part, we are going to cover part B. I can scroll back up, or you can just yourself quickly take a look at it. Find the sample variance, the standard deviation, range, and coefficient of skewness, SK2. And if we come back down, here we go, and we'll be starting the second part, or part B. So to continue, you have a standard deviation. Standard deviation is technically the square root of variance. The first thing you need to calculate is variance because that's technically what is under the square root, and divided by and subtracted by 1. That xi subtracted by x bar is technically your data points subtracted by mean divided by the total data minus 1. And by calculating that, you get the final value 10.02. The important part here is that you get the variance right, because that's the most important thing, and that's technically the main point with this, and that's the main thing under the square root that you see in the equation. And again, all it means is the data points that you have from I equals to 1, whatever data it is, all the way to your last data set, subtracted by the mean, uh, powered by 2. Sorry, I forgot to mention powered by 2, as shown on the equation, and subtracted by the total data that you have minus 1. Sorry, divided by the total data that you have minus 1, which your final answer is 10.2. Uh, that's the main point. Uh, there's nothing else that might be important here. And then the next part of it asks for range, which is simple. It's just the maximum value you have subtracted by the minimum value. You'll have a range, and the inner diameter is in a 36 millimeter range. And then you have a coefficient of skewness, which is 3 multiplied by the x bar, which is technically mean, subtracted by the median, divided by a standard deviation. And technically, a value of 0 for coefficient of skewness means that your data set is perfectly symmetrical or has perfect symmetry. If it's a positive value, it shows that the data set is skewed toward the positive side. And 0.75 is the value that we calculated for this based on what we have. Means 3 multiplied by mean subtracted by median divided by a standard deviation. Now you might ask why it's important. The reason that it's important is because, for example, if a manufacturer has a machine and the machine is like you're sampling the machine or the manufacturer production line, then you can judge whether it's a good thing or not, or what you need to adjust with the production line to get perfect things happening, right? That's how it can be important. It's just about the samples that you are having. Um, Again, with this question, everything is simple. The important part is that you get the variance right. Uh, what you need to do, again, I think I can draw on the screen. Just give me a second. I'm not sure. The important part, yeah, there we go. The important part is getting this right. And again, it's the first data or x1, whatever data it is, whatever value it is, minus the mean that you have, or x bar, powered by 2, and then sum all of them and divide them by the total number of the data set that you have minus 1, and you will have, and make sure that you have the square root here as well, and then you will have the final value. That's the most important part. Just you need to get the variance right? That's the most important thing. And then the rest of it is honestly super simple. For part C, which honestly I forgot what part C was, using the calculated statistics, can you comment on the quality of the tires? Well, can we comment on the quality of tires? The answer is there. Although the mean of the diameter are ideal, 570 millimeters, the variation is very large, 36 millimeter range. Median and mode are also below the target of 570 millimeter. That shows that the most sample points are below the target. Therefore, the production is questionable and needs to be examined and modified, right? That's why it's important. That's why symmetry and all those things matter in the statistics. Let me see if I have anything else to add here. I'm not sure. No, that's it. The main thing that you should remember. The next part asks you about provide a frequency histogram, report quality of these data along with a table summarizing the group data. Again, this is a very easy part technically. All you need to do is get the intervals right, mean midpoint, mean upper bound, and frequency of data. From there, you can easily set up a nice histogram. In the first tutorial, we covered exactly what you need to get in this data set, right? And that's super easy. The next question that we have is after the histogram, find the first, second, and third quartile, and then find IQR. Back to where we were. Here we go, part E. Now, this one might be looking a little bit frightening, but once you know everything is super easy. So let's get this started. Because we're dealing with quartiles, you need to sort your data. Ascending order is the best in the statistics. That's what everybody expects, and it's the best thing to do. So the first step is sort your data set, and that's the most important step for us in here. So this part is the easiest, sort your data. The next part is important. We have a bunch of values and data sets here. The most important expression we have is this one, n plus 1 multiplied by p equals to 3.25. Now, what does it mean? We are solving for Q1, which is 0.25 here, and then Q3 is there, which is 0.75, and Q2 is here, right? So now you can see where everything is. And the most important expression we have here is n plus 1 multiplied by p, which is equals to 3.25. Now, the n, we have it, the number of data set, which is 12. 12 plus 1 is 13. 13 multiplied by p. What is p? P is coming from the percentile that we are solving for. It's the same in all of them, as you can see here, here, and here, and the 75, the p that you have here, and the other values that you have there. So it's 13 multiplied by 0.25. The final value for that is 3.25. Now from 3.25 comes two things. Number one, k, which is this part of the value, and then 0.25, which is d, or the values after decimal. There's a whole bunch of different definitions that we can go through why these things are these and what do they mean. But I'll try to put them in very simple words for you. It might not be the most scientifically accurate, but it's simple so that you get it and you know how to use it. Technically, to calculate this percentile, you use the value that you have from k, which shows the position of the value needed for here. So if you go back to your sorted data, let's see if I can change this. There we go. This is the first one. This is the second one, and well, that was the second. That was a big number 2. So here we have the number 3, and technically number 3 is being used here in this equation. Now I can expand that equation, what that is for you. It's technically a statistical thing, but technically what you use here is the value from the position that you find for k, and then technically calculated for the rest of the things. Now, what are the rest of the things? You need to use some approximation here because your value is not exactly 3. It's 3.25, which means it's a value after the third value, right? To get this right, you, again, it's the simplest thing. Like I'm putting it in the simplest word. It's not the most scientifically accurate, but technically what it means is this. Once you find the third position, the value of the third position, because it's 3.25, you look for the value after as well, which is 566. It's not the fourth value, it's something between the fourth value and the third value. And for that reason, you need to create an approximation method here, which is this one, which means your value is 3.25, the third value plus a value after the third value, and that particular value for us, we're trying to like approximate that. And to do that, you find the fourth value or the value after the third, you put that here, you put the third one here, which we found, and then you multiply it by the percentile that you're solving for. This entire thing is an approximation method because this value is not exactly 3 nor exactly 4. It's 3.25. And we use this method, this entire thing, to approximate things and come up with an estimation. So you have 562, which is the third value, and the 0.25 after that, which are trying to approximate things. So your 25% percentile will be 563. The same thing will happen for the 0.5. As you can see, you put everything, you solve it, it's 6.5. It's not exactly, let's continue, fourth value, fifth value, and sixth value. Let me change the color of this. You have the sixth value here. Oh my God, that's not a good 6. There you go. And then this is the seventh value. Your value says it's not exactly the 6 that you're looking for. It's a little bit after 6, but it's not 7 as well. It's something between these two. You need to approximate that. And for that, again, use this equation, which you put the first number, the main number or k that we found, which is 567. And then you approximate between the two, 568, as you can see, subtracted by 567, multiplied by the percentile that you're solving for with your approximation method, you have the 0.5 percentile for 567.5 millimeters. Now this is technically same as median if you double check things. And let me clear everything for a second. There we go. So let's go back up to our median for a second. There you go. That's our median, 567.5. Exact same value here. That's what it means. Statistics is nice and easy, and it should work if you solve everything according to what you learned. So the next one is literally the same thing. The value is 9.7, not 9.75. It's not exactly the value in the 9th position. It's 0.75 after that. To find that, if you use the same approximation method, multiply it by 0.75 plus the actual value that we found, and it's going to be 572.75. Something that I noticed before is that sometimes people forget about this part here and they not solve it correctly. This value that you find here is normally within your data range, right? So you want it to be in your data range. For example, don't multiply it by 75. You need to multiply it by 0.75. So it needs to make sense, right? So that's a 70. That's what you're solving for, like 0.75, 0.25, 0.5. Depends on what you're solving for, right? Don't forget to use the decimals. With that being said, we have IQR, which sounds like fancy. Technically, what it is subtract Q1 or the first quartile, the 0.25, from Q3 or 0.75 that we found. And it's called interquartile range. That's what IQR is standing for. Fancy name, I like it. You just technically do that, and you will have technically the difference between the two for your final value or IQR. Super easy, super simple. I think we have one more, two more sections that we need to solve for. Part F, I honestly forgot what it was. Are there any outliers or extreme outliers in the data set? Great. This is a great question because we have an outlier and we also have extreme outliers, which we're going to describe what the difference is. Now, to solve this question, the first important thing is that figure out if there's an outlier first, and if there's an outlier, whether it's extreme or not. To get that going for us, we follow a very simple equation, Q1, the percentile that we solved for, subtracted by 1.5 IQR. That's why IQR is important. You technically plug in all the numbers that you have, all the values that you found, and you come up with a final value. Now, for us, after calculating this entire thing, that final value is 548.75, 548.375. Now, what does this mean? There's a final conclusion here. Therefore, there are no outliers nor extreme outliers in the lower end of data set. What does that mean? It means that this is what we found. And for anything to be an outlier, it should be less than this value. Now, forget the decimal part, 548. Let's go back to a sorted data set. Here we are. Take a look at the sorted data set we have here. The minimum value we have is 560, and it's not nothing is less than 548. So we have no outlier, which is less than the Q. We have no outliers on the lower end of the data set. If I clear everything, we calculated for the upper end. This time, instead of subtracting, we sum them. You have the Q3, or the percentile that we solved for, 0.75, plus 1.5 multiplied by the IQR. We come up with the final value. Now the question is, in data set, do we have a value more than 587? If we go up in a sorted data set, 587, I'm simplifying things. I am getting rid of the decimal. 587, and there's one value, 596, right? So there is an outlier. There we go. Now we need to check. Sorry, it's just takes me time to clear everything. So we have an outlier, only one, which is also in the conclusion. Therefore, we have one outlier, which is 596 millimeters. Now we need to calculate whether this is an extreme outlier or just an outlier. To answer that question, use the same percentile, but this time, instead of multiplying IQR by 1.5, you multiply it by 3, which is double the value that you have there. And you come up with a number this time. It's 602. The outlier that we have, its value is 596. 596 is less than 602. And it means the outlier we have is not an extreme outlier because it's less than 602. And that's what it means for the outlier and the extreme outlier. The only difference is that one is multiplied by 1.5, the other one is multiplied by 3. IQR is multiplied by 3, IQR is multiplied by 1.5. Let me clear all drawings, and I think this will be the last part that we'll be going through for this tutorial, and that's part G. For part G, again, plot a box and whisker chart of the data set. You know how to do that in Excel. Super easy. You just put everything in Excel. It shows the outlier, it shows and calculates everything for you as long as you're doing the right data set in Excel. And technically, with that being said, it's what we were supposed to cover for tutorial 2. If you have questions, let me know. If not, I hope you have a great rest of today. And again, if you have a question about the box and whisker, just go back to our tutorial 1 and you will find out how you can arrange everything and how you can show things on the graph or how you can hide things on the graph, and everything else is going to be shown automatically for you. You just need to set it in the right format based on the Excel file that I showed you in the first tutorial. With that being said, I would like to quickly recap important things. The difference between an outlier and an extreme outlier is that one is multiplied, the IQR in one is multiplied by 1.5, the other one is multiplied by 3. In a statistics, we normally try to sort data set in ascending order because it's really important, especially for calculating percentiles and finding other things, including the options that we had up here, such as mode or median. The mean really doesn't matter because you're working with all the numbers, but for median, mode is extremely important. Remember that we might have bimodal data sets. And one last thing I want you to remember is that when you're solving for a standard deviation, make sure that you're calculating your variance correctly. And that's the most important thing that you need to remember. And the coefficient of skewness, you already know what it means. And the equation for that is super simple. I hope everything works well for you and have a great rest of the day.